Okay, let's move on to multiplying complex numbers. When I'm multiplying complex numbers, anytime I'm dealing with complex numbers, I want to make sure that I remember my answers need to be in standard form. They need to look like a plus bi, real part first, imaginary part second. So given this first problem, when I do my multiplication of 2i times 4 minus 6i, 4 minus 6i is my complex part, I'm multiplying it by one imaginary number. So I need to remember my distributive property here. 2i times 4 would give me 8i, and 2i minus 6i would give me negative 12i to the second power. Now, I'm not going to leave my answer like that. That's not what standard form looks like. Standard form has no powers of 2 on I, so I need to make sure that I remember that I squared is equal to negative 1, and that 12 times I squared means negative 12 times negative 1, which would turn my problem into 8i plus 12. I want it in standard form, so I need that real part to come first. So I'm going to simplify my answer a little bit more, put that 12 in the front, and when I move it to the front, I make sure it has the same signs. Right here, it was positive 12, so when I rewrite it and put 12 in the front, it is still positive. And right here, 8i was positive, so when I rewrite it, I'll make sure 8i is still positive. I make sure that the signs move with my numbers when I rearrange them. Here, I'm distributing a real number to an imaginary number, so I'll multiply 5 times 6 and 5 times negative 7i, which would leave me with negative 35i. And that is in standard form, so that's okay, I'm done. Here, I've got a complex number times a complex number. Now, I need to think of it as I did number 1 and number 2. I need to think of it as distributive property. So let's take 3, and let's distribute 3 to the second complex number. So I'm distributing my real part first. That would leave me with 9 minus 21i. I've distributed my real portion, so I'm done with that one. Let's distribute our imaginary portion. So I would distribute positive 2i to the second set, which would leave me with positive 6i minus 14i squared. Oh, there's that I squared again. I need to know that it's equal to negative 1. So in the same step, we'll just go ahead and mark out that negative 1. That I squared with negative 1. That's going to change my negative 14 to be a positive 14. So my problem is now simplified a little bit further to be 9 minus 2i plus 6i plus 14. And then I need to combine my real parts with my imaginary parts, just like we were doing in our previous skill of adding and subtracting. So 9 plus 14 gives me a value of 23. And negative 2 plus 6 gives me a value of 4. That's a imaginary part, so I attach my I. And my answer is in standard form, so I'm done. Moving on to number 4, just another distributing. I'll distribute the real number to the entire complex second number. Gives me 30 minus 20i. Distributed my real number, now I'll distribute my imaginary. Negative 3i gives me negative 18i. And I'm watching my signs, being very careful with my negatives. Negative 3i times negative 4i gives me positive 12i squared. Going to go through some simplification here. I know I can't have a power of 2 on I, so I'll change that to be negative 1. So that actually switches my 12 to be a negative 12, and it's a real 12. Now I'll combine my like terms, and 30 minus 12 gives me a value of 18 for my real part. Negative 20i minus 18 gives me a value of negative 38i for my imaginary portion. And my answer looks like standard form. So I know I'm done. When I have a power of 2 on a complex number, that doesn't even look like multiplication, but I need to remember what a power of 2 means. That means negative 3i times itself, negative 4 minus 3i. And now I'll follow the same process that I did in number 3 and number 4. I'll distribute my real portion of 4 to this second number, complex number, giving me 16 minus 12i. I'll distribute my negative 3i to this second number, leaving me with negative 12i plus 9i squared. Going to skip a few steps here because I think you've got me with my I squared, or I hope you do. I squared becomes negative 1. That makes negative 9. 16 minus 9 is 7. And negative 12i minus 12i is negative 24. Had to check my math on that 7, make sure. There we go. All right, last one. I need to distribute here. My real part, that would give me 16 plus 8i. Distribute my negative 2i. That gives me negative 8i minus 4i squared. Let's extend my page here a little bit. I know I squared is equal to negative 1. That's actually going to make this be a positive 4. So that would give me 20. Then when I combine my imaginary terms, 8i minus 8i, those actually are inverses of each other, opposites of each other, so they cancel each other out, leaving me with 20. So I want you to note here in this problem that we multiplied a complex number by another complex number. We ended up with a real number, and that is possible when the terms are what we call conjugates of each other. This is an important word to remember. Conjugates. Conjugates take the form a plus bi and a minus bi. They have opposite imaginary terms, meaning that the opposite imaginary term is just the opposite sign. So the real part is the same number, but the imaginary parts are opposites. They have the exact different signs. And when you multiply a conjugate by another a term by its conjugate, you're always going to get rid of your imaginary portions and be left with a real number. That's important to remember.